Has anyone here played much with Perl's new OO model? Anybody? The new OO code, fields and classes and all kinds of fun stuff like that?
If they don't, it's Ruth's fault.
There we go. Yeah, that's it.
Wait, is this the talk on Sunday?
Yes.
Woo!
This is, in fact, this is the one that answers all the questions, hopefully. This was originally supposed to be 20 minutes, and they said, but wait, we need it to be an hour. So, the built-in OO, and this is not Blessing, this is a new class system that's built from scratch. The thing about it is it effectively, it's a neat idea. You create a class. When you create an object, you create a closure. And the object closes over the class contents. So, well, I guess, yeah, there was only one track, so everyone was here yesterday. These are basically what I'm going to be showing you from now on, are just another way of describing closures. The catch is that integrating all this into Perl's C source code is messy, as you can imagine. So, given that impatience is a virtue, Paul Evans created ObjectPad. And this is basically permanently beta code. This is the bleeding edge of what should eventually become the guts of Perl 5's object model, but let's try it first. So this gives everyone a chance to make mistakes. Please use it and be free to complain if you don't like something, because finding out what doesn't work is going to be critically important here, because we don't want to take something that's crap. As was pointed out yesterday, how many years did it take to not get Smart Match out of the source, even after we found that Smart Match doesn't work in Perl, it works in Reiko? So the goal of this is to find things that we don't want to be stuck with when they don't work. So please do try this and really scream if something doesn't function. This is an ecosystem. You're not expected to read all of these, but you get the funny feeling there's more than a few little add-ons that you can put into it. Some really fun ones, there's an operator of. That allows one object to illegally peek inside another one, which is mainly allows you to write really good tests and functional benchmarks, because you can peer inside an object and ask, if you wrote the object, is it behaving the way I wanted it to? Lexical methods, you have triggers, all kinds of cute stuff. But again, if people don't try this, we're not going to find out it doesn't work. The ecosystem, all of these things depend on objects that are based on ObjectPad. So ultimately, ObjectPad is where all this starts. If you're going to try and convert any of your existing stuff to try this, the first thing you're going to need to do is create classes, create objects using this new pad system. Really good pod in ObjectPad, but as usual, it's descriptive of the module, not really how to use it. A lot of what I'm going to be going over now comes from the Migrating from Classical Perl, one word, pod. You can find that thing on MetaCPAN. And it's a set of steps that if you followed them, you would get a working class and a working object out of something that began life as Perl 5. And the next few minutes of your lives. So a couple of things you're going to have to just accept. They're part of it. One is single inheritance. Everyone agrees diamond inheritance is a pain in the ass. One of the bad things that C++ foisted on us was all that diamond inheritance and the rest of it. There is only one fix for it: single inheritance. Every other mechanism, from Manhattan distances to MRO to everything else, leads to some form of madness. What you can then do, and this supports, is decompose the reusable portions of things into roles instead of separate classes. So instead of multiple inheritance, you've got single inheritance, and you can add behavior with roles at each level. Another thing you'll have to get used to is that you do not have a constructor. There's a new that is supplied to you, and it has standard hooks for cleaning things up. And that's what I'm going to be talking about. So this model is really well thought out. Paul's put a lot of work into it. He's talked to a lot of people, gotten a lot of feedback, but it evolves. some of what is documented in both the migration and in the object pad is historic. So there's some bad ideas that are documented simply because they're there, and it's hard to take them out now. So what I'm going to show you today is something that works. There are infinitely many ways to do this. This isn't more. This is like fractal hell. But what I'm showing you should work. You can mangle it however you like. So the real basics, and some of this gets kind of small. It'll get more readable as we go along. But if you've got a basic Frobnicate project in Perl using Bless, it'll probably look something like this. You got a construction, you got an initializer, a constructor, you've got a new, calls construct, it passes a init up the stack. In this case, I've got one attribute called verbose, and I've got one method called debug. And that's, enough to start something. It's just a base class for other things in a project. So if you said, gee, I want to use the IO pad, well, the first thing you're going to have to do is use at least 536 so that you can get the basic Perlisms for it, and of course, use object pad. One important thing about object pad, it is evolving. It evolves pretty quickly. Please make a habit putting the object pad version number when you use it. That'll save you a lot of trouble if you're working on machines, because just object pad isn't stable enough. If you run it on 2 machines and someone hasn't updated it, you're very likely to run into something that doesn't work. The next thing that happens is your package goes away, and so does all your initialization and construction. Your new just gets wiped, and you're going to create a class. Classes can take a version number. I habitually use v-strings just for simplicity. Eventually, this method debug is going to get swallowed by the class, and your attribute won't be a function. It'll be just declared as a field. So if you look at it, I've got this class Frobnicate. There are a variety of attributes I can give it. Those are those things with the colons. Have people played with attributes at all? Well, you saw yesterday like the attribute :L value if you're creating something. This is something that was added in Perl that just basically allows you to attach bits of behavior to subroutines. So the first thing we can have, you've got your class. The representation. A lot of people created their objects in the past by blessing a hash so that they could ignore object-oriented programming and just play with keys. You can use those as a type here. So if your representation is a hash, it'll allow you to do it. That's a crutch for dealing with existing things. Another way you can have is magic. Most of my stuff, blessed arrays, blessed scalars, you can use a magic. Native is whatever the internal format is. There's a newer format called PVOBJ that uses Perl's internal new object store as the way to keep the object. You're probably going to want to use that, but you have to be above 538, or 38 and above, excuse me. Another thing you can say is this is an abstract class. This is really sexy because it avoids you creating classes, objects that should never exist. So if I'm trying to create an abstract class to use only as a base for other classes, I can prevent new from instantiating them. Strict params is cute. One of the classic problems is you start passing things in and you wonder why your objects don't initialize, and then you find out you typoed one of the names that you were assigning with. Strict param says after all of the parameters have been stripped off the stack and applied to fields, give me a nastygram if anything is left. So the strict params is a really useful way to make sure that you're not ignoring some of the arguments that were passed in. But it also means you've got to clean off the stack as you're processing it. I'll show you how. ISA takes a single argument at most, and that allows you to inherit things. So if this is a that, you've inherited from that. But it only takes one. There is no multiple inheritance. Does is the way you apply a role into a class. So you can apply. There's also an apply keyword. I'll show you a few examples. Of course, this is Perl. There's more than one way to do it. There are a couple of advantages to each way for ISA and does, but you can use these today. And actually, the ISA will work and does will work in the existing, the regular Perl class. One other thing is, this is a matter of taste, the block can have a semicolon after it or not. It's like a subroutine. If you put a semicolon after it, won't hurt anything. It might make your code analysis tool a little bit happier if it sees a semicolon after the block, but put it there or don't, it's your choice. Inside the block is where everything you're going to define about this class goes. This is going to have your fields, it's going to have your methods, there's anything you want to know about the class other than these attributes goes inside this block. One thing is that fields are class scoped. They don't behave entirely like lexical variables. You have to read the documentation for a few edge cases, but if you think of them as lexicals in the scope of an object, then you'll be pretty much right. There is also a good document on file layout. You can use a block, you can use a class, and have a module-ish thing where it goes to the end. I'm going to show everything here as being inside a block, but there are other ways to do it if you prefer laying it out that way. Now, if ISA and does don't look pretty to you, you can use inherit and apply. And you can inherit from one at most, and you can apply as many rules as you like. The trade-off is ISA and does look kind of like line noise. There's just that much more cruft floating around. On the other hand, if you look at a code generator or a code analyzer, it might be happier with the ISA and the does because they're in one place. It knows where to find them. And it's also a little bit easier to not accidentally delete them from a place you can't see them. The advantage to inherit and apply is you can stick them in the block as you're going along, and it's just a little bit easier when you're scribbling it out. And the other thing is they're a little bit future-proof. The inherit and apply might be able to take attributes of their own. So you might be applying only a selection of methods from a role or something. So the apply might give you a richer way to define the acquisition of the role. There's a PV_obj if you're going to play with this and you're starting over and you've got, let's say, 540 or later. PV_obj is probably the best way to represent your stuff. It's going to be the most efficient because it uses Perl's internal mechanism. So that's what the stuff I'm going to show you here looks like. In the case here, I've got a field called verbose and a method called debug. And debug can see $verbose because it's a method and it's within the class. Does that make sense? It's going to behave a lot like a lexical variable. And again, if you think back to the closures talk, you've got a subroutine or a do block or something that keeps a bunch of values alive inside of a sub. This is a closure. It's the object that keeps a collection alive. So each time you instantiate a new object, you're going to create what's in the block, and it's kept alive because it's referenced from the object. And then when the object goes out, all of that content gets wiped. So a method, when you declare it that way, has a $self. Frankly, I hate $self because you look at two subroutines from completely unrelated things, and you wonder why something doesn't work, and then you realize, oh yeah, those are different $selves. But self is what we've been given. If you have a class method, and I'll show you what those look like later, but the difference when you see them is they'll use a sub rather than method. They have no self. So you have to deal with the stack on your own. So you'll have to shift off a class name or an object, whatever. But for class methods, you don't use method, you use sub. So this is a working basic outline of a class. You've got Perl, you've got the object pad, and you've got a name, attributes, and some block that describes it. Making sense? I'm going to try and go pretty quickly because I've got about 90 slides here. So defining fields, that's the next bit of fun and games. So if I have a field, I can have a writer, a reader. There's a self that gets returned from those, which allows you to daisy chain things. So in this case, if I have a field verbose and it has a reader and writer, I'm going to have a verbose method that allows me to read it, and I'm going to have a set verbose that allows me to write it. So the writer creates a set where the reader creates a thing with the name of the attribute. You can add your own attributes, accessors. If you don't put reader and writer after here, then you won't get the automatic ones. You'll write your own. No harm. If you have a reader and writer, then it's a bad idea to make your own, and you use one or the other. And things that you would use your own reader and writer for, let's say you're storing things as enums. People pass you strings, you store them as numbers for compactness, and then you get them back out again. So you can do whatever you want with the accessors. If you don't like verbose versus set verbose, which confuses people, you can pass a name to the reader, and you can call it get verbose. So you can have a get verbose, set verbose, if that's the standard you're using. You can put whatever names you want on these things. Now, one other neat thing, I use L values a lot. So you can create a mutator, which means you only have one name. So you don't have to worry about set things and get things. You can assign it, you can read it, and you'll have something like frob points to verbose to read it. You'll assign to frob verbose. Looks kind of Reiku-ish. At that point, you create mutator, and you have a $verbose. Now, one thing to think about, these readers and writers have no boilerplate. They're not going to do any translation. They're not going to check anything. They're not going to format anything. If you have something more complicated than a simple verbose flag, you probably want to hardwire your accessors, because you're going to want to do something. If your field is a file name, then you're probably going to want to have the setter do something ridiculous like check that it exists, not empty, that it's readable. There's all kinds of fun things you'd want to validate about something when you allow it to be assigned. So whatever sanity checks you want to put into things probably belong in those accessors. I'll show you how to do that in a minute. You can also have, and this is an example here, let's say we have our method as debug and people get confused. Do I set the debug flag? But then if I set the verbose flag, why am I not calling verbose? So in the process of converting this, one of the things you can do to make life happier for people, I can change the name of this mutator to isDebug. And now you know that isDebug is turning on or off the debug method. It's turning off verbosity in the debug method. So you can do things like that when you're making this change. By naming your mutators, you can help people understand what they actually do. If you want to have a role, you can use a does. So in this case, frobnicate now does logger. Because you think about it, just dumping out, setting verbosity and dumping out something on debug mode is pretty reusable. I might have more than one class that wants to do that in different ways. Also, I can have a method called info, let's say. Info just ignores the verbosity. So it would look something like this. I've got does logger. My field verbose doesn't change, but now the logger has its method debug and info. I can call frob to debug, frob to info. I can't see the moon phase. I picked that out of the sky, but the point is that a role's fields are private to the role, just like a class's fields are private to the class. If you want to have roles adding attributes that people can access, put a reader on them at least, or a writer, or a mutator. Do something, because the values themselves, the fields are private to their encapsulating scope. Oops. Does that make sense? Because in some languages, if you add a role in, you can access its fields also. That's not true here. So in this case, I've got the logger, I've got debug and info. If I want moon phase, I have to access it as a method. I can also say apply logger. The one thing is the existing Perl mechanism has a :does attribute. This apply is something that's an object pad, so that it may or may not make it into Perl's core. So think about that, but it's an artistic decision. You can have one of these, you can have one of those. They both work. Requires is a neat little thing. All of us have been in the situation where you use something and you discover halfway through a 1-hour run that there's a method that isn't defined somewhere. Wouldn't you rather find that out when you test it? So roles have a requires. What that says is, in this case, if I require verbose, any class that uses me has to export a method called verbose. In this case, because I have a mutator, my field verbose has its mutator method. That means that the method debug knows that it can access self to verbose in the class. And that requires does the check at compile time when the role is compounded into the class. Does that make sense? It's a really, really neat idea to put lots of nice requires in your roles so that you don't blow up during execution. Now, this is a pretty good division of labor here. The field for verbose is in the class. And you say, why not put it in the role? But the class might have a better idea of when it wants to set verbosity. It might say you have to set verbosity in some places. You don't want to set verbosity in others. It might have different accessors. It might be read-only. Different classes might have different ways they want to manage that flag, but they all still want to be able to do the debug. So having fields in your class that are accessed by methods in the role gives you a pretty good division of labor for doing that. Does that make sense? Everyone with a heartbeat, raise your hand. That's fine. Okay, I haven't killed anyone yet. One neat thing that is a short-term fix you can add to a role is invocable. This attribute says, if you give me an object that is not directly derived from object pad, I won't puke. If you don't put this in and you put your old blessed thing through here, you're going to have problems. So this is a crutch. What this allows you to do is take behavior that is role-like, take it out of your module and put it into a role, take what's left and put it into a class, and not have to rewrite the guts of all your bless system up front. You can start managing and testing the roles and just see how it fits together without having to go through all the steps to decompose your object into its own fields with accessors. So this is a crutch. It allows you to migrate into the roles without having to do all of the work to fully refactor what's left of your module and your package into a class. It's a crutch. It makes perfect sense to use it during the transition phase, but you'd expect to remove these before you're done. Does that make sense? I'm getting some nods. Okay. So there's a new. The new operator, everyone's got their own ways of passing arguments up to now. We've seen all the crazy mechanisms there are. The new that's here in Object Pad is a flat key value. No hashes, no hash refs, no whatever. There are a set of phasers that you can use to manage how it processes those arguments, but they come as a flat key value list. What I'll show you today are build args and a build and adjust. And in fact, build is left over from a time when they were trying to duplicate Moose, and you probably shouldn't even use it. So if you understand build args and adjust, you'll be able to get through all of this. So a param on an attribute, in this case the field bar :param says I want this to be a parameter to new. I'm going to set it from the constructor arguments. So in this case I'd be setting bar to 42. What happens then is all of the ways people have done it, positional, I've worked at a place where everything had to be attribute equals whatever, people that use pluses and minuses, passing in a JSON string, all of those go away. You're going to just flatten everything out. If you want to pass in a JSON string, fine, call it JSON. But it has to be a key, and a value. That is what new will accept. Now, day one, everyone isn't calling you that way. So there's a way to handle it. What happens here, though, is if I look at verbose and I've got a param, you can call this with new to verbose, and I'll get it. Without a default on here, this is a required argument to new. So everyone must pass verbose in because there's no other way to get it. To default it, the easiest way is you just have equals something, and that will be an assignment. That's an optional assignment. If there is no value, it'll be assigned this way. It looks just about like Perl signatures do today. So in this case, I've got E and V of verbose, or nothing. So now I've made this an optional parameter because I'm giving it a default. Problem here is E and V of verbose is global. It can change during my execution, and that'll show up as you're running something and some third class changes verbose in the environment, and all of a sudden you start spewing out debug output you didn't want. So to get a stable version, you can put this for example, in a do block. By using a state variable, I can have, a state variable, I can have a stable value that gets returned for everything. If what I have is a little bit more complicated, I can create an anonymous subroutine. Basically, that acts like a private method, and I can say, fine, whenever you have something, if it doesn't have a value, execute the default verbose function. Or I can have a mySub, which is newer, and I can say equal to call this function. This is a pretty nice way to do it because then anything more complicated than setting it equal to 1 is put out, but you know that it's somewhere in the class. You can find it. It's not going to be scattered all over the universe. People see how this would work? Another way to do it, if you really want to have fun, is you can create a trampoline object. And at that point, I can have the most complicated thing on the planet that reads a config file, grabs it off of the, yeah, I saw it. I'm halfway. You can have something pretty complicated that takes a long time to process. You can amortize it over the runtime by creating a trampoline. That'll work just the same way. The first time you hit this module and you actually want to assign a default to verbose, then you'll instantiate the object. One neat thing you can see from this, though, is that earlier fields are visible later in the module, so in the class. So if I have my $config up here as a field, down where verbose is defined, I can see $config. So again, these behave like lexical variables. If you've got a stack of lexicals, you can assign one, define more from it. This is really nice for doing a lot of things to initialize non-parameter fields from parameters. The prob to config to value, that works. I'm going to go pretty quickly through a few of these. You can get a default from a role if you have a config reader, and this thing does config read. You can call a role method to assign the default. And again, that allows you to reuse these configurations, and it shows you how to merge these in. If I have, the nice thing about doing that is once I've put that definition to a role, if I need to expand the capabilities, let's say I want to be able to open or read, I want to reset something, I can start merging that into the role without having to modify the class. So I can add functionality that I need it without having to hack the class every time. Interact on assignment. Another nice thing I could do is take an initial verbose and default it, and then set my verbose from the current value. So verbose equal current verbose equal init verbose. Now what happens is I can create a reset. If you see what this will do, I can have a param field that gets a value, I can get an initial value that's a default, and if I want to reset things, I've stored what you gave me the first time, and I just reuse it. So I can stack the fields. It allows me to reuse them. I can have an initial value and a current value, and just assign one from a param, assign the other when I create the object, and reset it to the original value. Build args comes right before you process all this key value stuff on the stack. So I've shown you these parameters. The point of build args, it's a method that takes the stack. It's a regular subroutine. So it doesn't have a self. It does not have access to the object yet. The object isn't built when this is run. But what you have is a list of what the stack is going to look like when it is passed into new to get the parameters out. So, for example, one way to do it is this. I just ignore the prototype. If I think that everyone's passing me key value already, I can just assign it to a hash. But let's say I'm in a place where all of our existing stuff is case insensitive and people use uppercase verbose. Now it's case sensitive because it has to match the name of the field. So I can go through, I can take all the arguments that have any uppercase letters in them, force them to lowercase, and then hand that back. Now, one thing to notice is that I'm deleting, I can make the person work, I'm deleting the args. You're actually manhandling the contents of this. You don't want to leave leftover garbage in here. So if you modify one of these things and put a new key in for it, you want to take the old one out. When you're done, whatever you hand back is the @_. What'll happen then is this loop of class to build args @_ gets cycled through this will get called for whatever you're constructing. This will get called once for whatever you're constructing. Gets the key values. So again, one place I worked, we had A = B was the notation. So if you do that, I'm going to have to take the entire stack, split it on equal signs, make a new flat list out of it. Fine, we're done. You can assign defaults here. People will say, well, why can't I assign a default? You can. The bad thing is if I take this env of verbose out of here, looking at that field, you have no idea whether it has a default or not. And it's really easy to mess up the default in build args or delete it by mistake because you don't realize. So probably leaving those defaults attached to the fields and taking complicated ones, dealing with them as functions, is a better way so that you get everything in one place. It makes the whole thing a bit more declarative. If you want to chain, if you've got multiple classes that think they have build args, use this. You have to come in, daisy chain to the more base classes, and then the most derived class gets to hand it all back. So take the prototype off, call super. If you don't know if that exists, look up the next module and call next. But you're going to have to go and do the daisy chaining yourself. If you have to do anything that modifies, let's say you've got this derived class here, if I know that there are a couple of parameters on the stack that once the most base class is left as a flat key value, that there are a couple of values that have things that need to become parameters, fine. Do whatever I need, but then delete those off the stack and hand it back. So you have to hand back a cleaned up key value list. That's the only point of build args. After build args, the stack is now flat. The new operator goes down all the fields that have a param, and it says, do I find something in this hash that matches your name? Case sensitive. It just, if there's verbose, it goes in, key verbose, flags it as used, keeps going. Once all of that is done, any defaults are used up. At this point in execution, if there is a missing value, it is fatal. Vital, as Damien would say. You've seen that talk. White sharks, and anyway. The point is, if you are missing a parameter after build args is done, the next thing that happens is you will puke. Now, you might have fields that don't have a param that you have to build or construct. So what happens here is there is a build thing. This is taken from Moose. Don't use it. Well, the problem with it is it's fired off before the object is constructed, once for each layer of the stack. It doesn't have access to self. It doesn't really have access to a complete object. It can't call methods on the object to set or validate things. It's really hamstrung in what it can do. So it's there, but it probably isn't the right way to do it. A better way is adjust. The adjust can be called with parameters. You can have it take specific things off the stack or just take the whole stack into a hash. It has a completely constructed object. All the parameters are put in. It has $self, so you can call methods to keep going. And because it has access to a completed object, you can use roles or the actual class definitions to have validators to make sure that things work. So this is a named block. There's no subroutine on it. You can say :params and give it %args, like we saw with the build args. This will give you basically a tied hash that if you delete things from it, you will be cleaning up the stack that is used to validate in the final stage. So here I've got a list of parameters, and I can say I can dump what the parameters are. I can do whatever I want. I play with them. An example here, again, I got self. Speed up. So the adjust here is a good example of where I need an adjust because I can't use params. Let's say I've got something that's a unit vector. You give me an x, y, and z, I compute a magnitude, and I scale the values so that they're within a unit. Well, I can get parameters for x, y, and z, but I can't tell that they're not a unit yet. And I can't use them alone to compute the unit. So what am I going to do? I go into my adjust block, and I start with all these fields. Notice mag doesn't have a param. I can't trust you to compute the magnitude properly. So what I'm going to do, I'm going to start by saying x and y and z, if you give me a 0 magnitude, I'm dead. Now I can compute the sum of the squares, and this is a good use of adjust because I can validate the fact that you haven't blown the precision off the top. If you give me a bunch of numbers that are too small, squaring them is going to give me a bunch of zeros. So at this point, if my sum of squares isn't greater than 0, I got a problem. Now I can scale all of these, but I still might have a precision problem because at least one of these has to be greater than 0 when I'm done. So this validation is complete. At this point, I've got a working magnitude. Quick aside about carp. Ever hear carp not? People use that frequently. Most people don't. This is a real lifesaver with this. You don't want to use confess because you're going to have umpteen layers of object pad in every confess. You don't want to see all the layers of object pad that you don't really care about. You want to see the idiot that called you with a bad parameter. If carp not is object pad, then the first thing you're going to see in a croak or a carp is the place that went into object pad, which is where the call to new was, which is what you wanted to see. So it's worth putting this in, use carp, but then use carp not to keep object pad out of your stack. Otherwise, you're just going to see the place that object pad called you, and it's not going to tell you enough. And confess is going to be a real pain in the butt because it's going to get very, very thick with this stuff. So adjust cleans off the stack. Another thing might happen if I have multiple people calling me and they have different argument standards. One might call them credential, one might call them authn. I've got two different things to clean off the stack for the same value in my object. That's another place where just params don't work properly because you're going to have more than one thing used. So again, here's my DSN is whichever I find of these. Delete them both out and take the first one I find. I can also have, with params of args, I can have params with the variable names. So in this case, I know the two things I might be cleaning off are creds or authn. Let me take just those, put those as params, and I will flag them as having been used. By doing this, the check phase knows that those have been consumed. And again, I can get whatever I need from both of them. I don't have to worry about different people calling me different ways. So this is another use for adjust to standardize things. Strict param checking, if you had that strict params, runs now. And it says, is there anything left on the stack? And you get a nasty gram about unused parameters. This is all the ones that people misspelled and used the default by mistake. We've all been through that. Anyway, there's a thing called adjust args. I don't have time to describe why it doesn't work. If anyone cares, that'll be next year's talk. But the way it works, the problem you get from it is that it's very easy to misalign the parameters in adjust args and not realize what you're checking. And this is actually sufficient to create a working class. This is, if you take you break out usable roles from your existing package, you have sane fields out of them, you get stable defaults for your values. If you have a reasonable inheritance, that's the best you can do. The param fields with defaults automate just about everything. You use build args. I would suggest just doing the KV pairs and stopping there. You can do a lot more. But every time you make build args any more complicated than it has to be, you'd be better off doing that same work in the adjust. There isn't that much syntax here. A class, you've got these few attributes. The ones you'll use are here, the repr. What's the internal representation? Ultimately, once you've converted everything to object pad, you'll ignore it because it'll default to the most recent, the most advanced one it can find. Abstract is something you might or might not use, again, if you want an abstract class that you shouldn't create objects out of. And the does and is for inheritance and roles. A role has the compatible. The thing to remember there in the roles is the requires will save you a lot of pain. Fields might be parameters, they might not. The reader and writer for defaults, the mutator if you want to use L values, and assigning a default to it. Take your build args, make the key values, take the adjust, use that to populate anything that doesn't easily fit on the stack, and that's it. The couple pieces of things, object pad has good documentation, but again, it documents all of the bad decisions that were made also. So there's a lot of documentation in things like the build for things that might not be a good idea. Migrating from class, again, it's actually getting a bit old, but it shows how to take a simple class and a simple module and convert it to the new class system using IOPad. And that was it. Whew. 45 minutes. Quick poll. Did most of this make sense to people? Does it seem reasonable, like you'd actually try to use it? Well, okay, you're weird. But no, aside from the couple of people here, I've played with it, he has. But if for the people who haven't tried it yet, is this something you'd be likely to look into? This will be up on my speaker deck. I think the APSI will have this online. You can feel free to refer to this. The migration document is in here. If people have got questions about it, or if this didn't answer something well enough, warn me because I can update it. Are there any questions? Rotten Tomatoes? Yeah, a question. The what? Role, basically, let's say I've got something reusable. Let's say every one of my classes has got a method in it called debug. And every one of the debug methods checks if the class verbose before it prints out. I've reproduced debug in this class. Every single class has got a debug. That's a waste. I'd rather have one copy of debug to maintain in one place. So I would go in, I'd create a role, frobnicate : debug. I put my method in it. it would use the class to find out whether verbosity is turned on. Now I can take that debug sub out of every place. And I can does roll or debug, printing or debug. And then that one thing in one place gets reused by everyone through the roll. It avoids multiple inheritance. That's the way to do it. The point of having roles is by avoiding multiple inheritance, you avoid diamond inheritance, if you know that problem. I have two things that come from different places. Well, with roles, all I'm compounding into the class is the method. So if I have the class with verbose in it, and if my role uses the method to access the value from the class, then the role can be reused all over the place, and it's going to look into its particular object's class to find the values that it needs. So each object is going to have its own verbose value. That's fine. I don't have to worry about diamond inheritance and different things managing different values in different ways, because each object has its own copy. Each layer of the object, each class can define its own thing, and then its role looks to the object to get what it's doing. And again, yeah, it's a way of avoiding. You can get into spaghetti code with roles also. It's one way to look at it. Yeah, well, he was just, the comment was that you can think of a role as the inverse of an abstract class. An abstract class says, here is a class that doesn't instantiate a bunch of things that it knows that it needs. A role is a bunch of things that are supplied, but you can't construct one of it. So it fills in the needs of a class that doesn't instantiate those methods, and the role supplies the methods so that they become reusable. The class doesn't have to. Another reason for doing it, you might have something that's never reused, but at some point the class takes up 55 pages. No one's going to maintain it. If you break the functionality down just for maintenance purposes, I might have the package, the abstract class might have a group of things that do output, and another group of things that do configuration, and another group of things that manage object state. You can take those and push them out into roles just so that you have a smaller unit of code that's more consistent, and you're not having to weave through all the garbage to find what you need to look at. If you have a configuration problem, you know it's in the configuration role, not in the printing. Yeah?
All right, so am I right then in assuming regarding compat invocable that the main reason it was trying to turn these packages, I guess, into roles is because that, in fact, does avoid multiple
Well, what would the point of invocable is, let's say you just walked up to your package from hell. It's got 85 methods, most of which belong in roles. You've gone through the motions of defining 6 roles and slapping all these things into it. You still have to go back and change the core class. Well, the stuff that you've got that's all written today is still using the structure from that package where it looks at $foo points to curly brace and it goes into the hash and it hacks the hash. Well, I don't want to force you to rebuild all of the code everywhere in one pass. So this allows you to, that invocable just says, look, I've started with my one package. I've got my blessed object that was whatever. And at that point, I can break it into roles. I can leave the constructor pretty much alone. And I can now call these role methods from the class. I have my own new. I don't have to take the basic structure and put all of it at once. I can validate that the roles even work, and I haven't left a function out of something, and they can all see each other. Then the next step would be to go into the class and get rid of all those hash accesses. And I'd have a Reaper hash that the roles were using so that they knew they were getting something flaky. Does that make sense the way? And it just, now, once that much is done, I can go back and convert all the roles from using hash access to using attributes and using methods to access it. Then I can go back into the hash and into the class and rip out the rest of that stuff and use the params. Did that finish answering your? Okay. I've been told that I'm done. Yeah, there's a beer on that one. That's what I need. Let's see. Let me get my screen off here. He told me I'm done. Blame Ruth.